Hello, I here once again to tell you more about graphics processing unit. There is one that has been made by Qualcomm, and it is called Adreno graphics processing unit. The main reason or the main purpose of a graphic processing unit is to process graphics, just like the name suggests. Now, Adreno GPU accelerates the rendering of complex geometries to deliver high performance graphics and rich user experience with low power consumption. Now, Adreno graphics processing unit is meant to be part of a processor, or it is part of a processor that is used in mobile phones and premium devices that we use frequently. Now, when we are looking at the requirements and what this GPU is able to deliver, there are many. It has got even advanced API support. So it supports APIs such as OpenGL. Apart from that, in comparison with other GPUs that were there before, it is able to give 50% better performance than the previous one, 40% power efficient than the previous GPU. It's also faster than the previous one. Now, this CPU is very important. Now, I want to take you through how the GPU works. Now, if you look at the diagram that I have for you on the screen, we have the CPU, which is the main processor. And also remember, graphic processing unit is also a chip by itself. It is a processor by itself. It is a form of a CPU, if I may say so. Now, as you can see, we are able to see the dotted line encircling the Adreno GPU. There is the bus. Now, that the bus is basically what is able to transmit and transfer data and signals. We also have the buffer frame within the system memory. There's the display processor. We also have the audio OpenDSP, and we also have the system network on chip. Now, these are the components, just a diagram that represents the internal structure of a Snapdragon processor. Now, Snapdragon processor consists not only of the core processors, but it also consists of the Adreno GPU, which is part of it. And I just want to take you through the process of image or graphics processing within this device. Now, normally the processing begin from the CPU sending commands to the GPU, and the GPU receiving those commands. Now, these commands that are received or accepted from the CPU serve as the primary context from where the whole organization or the whole processing of image starts. Now, the GPU receives command from the CPU, which serves as the primary processor. So the CPU is the primary processor. Now, these commands provide guidance for producing graphics, such as setting, rendering states, applying texture, and even drawing. Now, after communication, after the reception of the commands and the guidance have been provided, the second step is what we call the vertex processing. Now, the GPU processes the vertex data provided by the CPU. The vertex data define the geometry and attributes of objects in a 3D scene. Now, the GPU perform transformation on the vertices, such as transformation that are being articulated or that are being done at that moment is basically translation, rotation, scaling, including light calculation. So those are some of the tasks that takes place during vertex processing. Now, the third step is geometry processing. Now, after vertex processing, the GPU performs additional calculation on the geometry to prepare it for rendering. Now, these include tasks such as culling. So culling is the removing of objects or parts of objects that are not visible. Then there is this other element which involve ensuring objects are within the view frustum, and that is what we call the clipping. Apart from that, there is also what we call tessellation, breaking down complex geometry into simpler primitives. So that form part of the geometry processing. Now, the fourth step is rasterization. Now, rasterization is the process of converting the transformed geometry into fragments, which are essentially pixels on the screen. Now, the GPU determines which fragments are covered by the geometry, taking into account factors such as testing and stencils operations. Now, that form step number 4, which is rasterization. Then step number 5 is what we call fragment processing. Now, at this moment in time, or at this particular instant, the GPU perform calculation on each fragment to determine its final color and other attributes. Now, this involve operation like texture mapping, applying of texture to surface, shading, calculating lighting and materials properties, blending, and even combining fragments with existing pixels on the screen. Now, that is step number 5. Step number 6 is pixel output. After fragment processing, the GPU outputs the final pixel value to the frame buffer. The frame buffer is part of the system memory, as you can see from the diagram. Now, what it does, it is able to store the colors values of each pixel on the screen. Then step number 7 is what we call display output. Now, the GPU sent the content of the buffer frame buffer to display controller, which then displays the rendered image on the screen. So that's how the processing of graphics takes place in a GPU, or graphic processing unit. I hope this video was informative and it is able to help you understand what normally goes on within the GPU when you're using it on your device. So thank you for joining me. Remember to like and subscribe. See you